So hey coding words. So basically in today's GFG POTD we have a problem, the smallest positive missing number. So basically it is a like medium level problem, and as a problem asks that you are given an integer array R. Your task is to find the smallest positive number missing from the array. So here note is actually also given here. Positive numbers start from 1. The array can have negative integers too. Okay, so that means let's say if you're talking about this particular example first. So here we can say here in the array negative integers are like also present as well as positive integers are also present. So what our task is to take the smallest positive missing number. Like if we are talking about this one, so 2 is not actually the smallest positive number. If we are actually seeing in this particular example here, so if you're targeting only positive numbers, so it will be like 1 2 3 4 7. So like while traversing inside the array, we can say here 6 is the element which is like missing in between this particular range, like from 1 to 7. Okay, similarly if you're talking about 1 2 3 4 5, here it's present. So the next smallest positive missing element is like here 4. So here we have to like return 4, as it is 4 is like also like missing from this particular array. As we can see, this is the examples which are having mostly negative numbers like -8, -1, -4, 3. So we have to completely neglect all those numbers, and we have to also like don't consider 0. So the minimum value will be like 1. So with the smallest positive missing numbers will be like 1. So basically this problem is like asked in companies like Ecolite, Amazon, Samsung and Snapdeal. Talking about topic text, so it is like based on arrays, searching, data structures and algorithm. Okay, and real rated interviews experience, so it is like asked in Samsung, Snapdeal, Amazon, Ecolite, Amazon interview. Okay, like that. And we will solve this problem with an expected time complexity of order of n and expected auxiliary space of order of 1. So let's understand this problem first. So first of all, for solving this problem, I've taken here the first example in the whiteboard here. This is example 1 here, which is like 2, -3, 4, 1, 1 and 7. So basically for solving this problem, first of all, what we have to do, here we have to create um, another array of size this. That means I is like less than array dot size, which is like less than or equal to 10 to the power 5, and array of I is like greater than or equal to -10 to the power 6 and less than 10 to the power 6. So first of all, we have to create another type of array so that we can perform this particular questions with a time complexity of order of n. Okay, so here I have to define int, let's say brr of size 10 to the power 6. That means 456. Initially I have to initialize with zeros. That means in the starting, all the elements at the indices in the brr array are actually getting placed by 0. Now after that, what we have to do, here we have to traverse for int I is equal to 0, I is less than array dot size. That means here we have to traverse inside the array, and then we can say I plus plus. And what we are actually doing here we have to say, here to give the condition like if array of I, because here we don't have to like consider negative value as well as 0 value. So here we have to say if array of I is greater than equal to greater than 0, not equal to greater than 0, because we have to also neglect 0 also. Okay, so what we have to do basically here, we have to make array of brr. Okay, array of brr of I, we have to make it as 1. That means whatever is the array, not in this but inside brr. Okay, brr of array of I, we have to like make changes inside the brr variable. So if we are checking about this particular example, so here we can say that 2 is the number which is like greater than 0. So here we have to make it 1. Okay, while traversing, 3 is the -3 is actually negative number, so here we don't have to take, and then we have to say take 4. Then here we have to like take 4, because when a loop is like traversing, it will like traverse it completed, which is having like 1 2 3 4 5. So it will take traversing 5 times and it makes 5 value. Okay, 1 2 3 4 and 5. all those positive numbers are like getting changed by the value 1. Now what we will do, we are going to perform this thing, like once we have like done these things, we have to traverse inside the BRR. So for int I is equal to 1, here we have to say and I is less than 10 to the power 6, 3, 4, 5, 6, and then I plus plus. And here we have to say that if BRR of I is equal to 0, that means whatever the value we are actually getting first, that is the basically the index which are having least positive integers. Okay, least positive missing integers. I return I. Okay, let's try to compare and run. So yeah, its compilation is completed. Let's try to submit it. So it's submitted. So that's all for today. Thanks for watching.